We're surrounded by AI every single day, but have you ever really stopped to think about what makes them tick? I mean, why is your search engine so different from a chatbot? It turns out they're actually built from the same basic toolkit, just put together in totally different ways. So today, let's pop open that toolkit and see how it all really works. And that really gets to the heart of it, right? Why isn't there just one mega AI that's amazing at everything? Why does using a search engine feel so completely different from, say, getting help from a creative writing assistant? Well, the secret is in their blueprints, what we call their architectural toolkit, and we're going to unpack it piece by piece. Okay, so to get this, we've got to go back a bit. We need to understand the huge challenge that AI researchers were up against for decades, just teaching a computer to understand human language. Not just the words, but the context, the flow. It sounds simple, but it's way, way harder than you'd think. So the first crack at this involved models called Recurrent Neural Networks, or RNNs for short. The whole idea was to make the AI read like a person, one single word at a time, moving from left to right, trying its best to remember what it read at the beginning of a sentence so it could understand the end. And this is where you can really see the problem. That old way on the left was just painfully slow. And because it was reading word by word, it had this terrible short-term memory. I mean, it would literally forget the beginning of a long sentence by the time it got to the end. But the new approach on the right, it's like night and day. It sees everything all at once, the whole picture. And that was a complete game changer. So the big question is, how did we make that massive leap from one word at a time to seeing everything at once? Well, the whole game changed in 2017 with this one revolutionary research paper that introduced a brand new idea, and its name pretty much says it all. Yeah, and this timeline really tells the story. Before 2017, everything was stuck in that slow, sequential lane. Then, bam, the attention is all you need paper drops, introducing what's called the transformer. And after that, well, it was just an explosion of all the models we hear about today, like BERT and GPT. So what is this attention thing anyway? The best way to think about it is like this. Imagine you're a student and you're highlighting the most important words in a textbook chapter before a big test. That's basically what self-attention does. It lets the model look at an entire sentence and figure out which words are the most important for understanding the meaning of every other word. It helps the AI focus its, attention. And that was the breakthrough. By letting every word connect to every other word at the exact same time, the model didn't have to read in that slow one-by-one line anymore. It could finally process language in parallel. And what that meant was we could suddenly train these AIs on absolutely gigantic datasets. We're talking huge chunks of the internet. And we could do it fast. So this new transformer architecture, the one built on attention, it basically handed developers this amazing toolkit with two core tools inside. And these two tools are the fundamental building blocks for almost all modern AI. Let's meet them, the encoder and the decoder. First up, we have the encoder. This is the understander. Its one and only job is to read a piece of text and completely grasp its meaning. It looks at every word, how it relates to every other word, and builds this really rich, deep understanding of the context and the nuance. You can think of it as the part that truly gets what you type into a search bar. And the second tool in our kit is the decoder. This is the generator. Its job is to create brand new text. Now, unlike the encoder, it actually works one word at a time, sequentially. But here's the clever part. It can only look back at the words it has already written. This is huge because it stops it from cheating by seeing the future. This makes it a perfect storyteller, weaving a coherent story one word at a time. Okay, now here's where it gets really clever. By using these two tools, the understander and the generator, either by themselves or bolted together, you can build fundamentally different kinds of AI, each one a specialist designed for a specific job. All right, so check this out. You can mix and match these tools to get totally different results. If you combine an encoder and a decoder, you get a model that first understands a language, then generates a new one. Perfect for translation, right? But what if you use just the decoder, the generator? Well, then you get models like GPT, which are awesome for creative writing and chatbots. And if you use just the encoder, the understander, you get models like BERT, which are absolute masters of search and analysis. So we've got these incredible blueprints for AI, but how do they actually get smart? It's not just about the design. It's about a really cool two-step training process that turns them from a blank slate into a seriously powerful tool. And this two-step dance is key. It starts off really broad. building a general foundation. And then it narrows its focus to become a specialist. We call it pre-training and then fine-tuning. Pre-training is basically like giving the AI a library card to the entire internet and telling it to read, well, everything. It just consumes terabytes and terabytes of text. And by doing things like predicting the next word in a sentence, it learns grammar, facts, common sense, and all the subtle ways that ideas connect. It becomes a generalist. So after pre-training, you have this AI that knows a little bit about everything, but it isn't an expert in any one thing. That's where fine-tuning comes in. This is where we take that brainy generalist and turn it into a specialist. We train it just a little bit more, but this time on a very small, specific data set for one particular job, like analyzing legal documents or answering medical questions. All right, let's tie this all together. We've got our toolkit, the encoders and decoders. We've got our training manual, pre-training and fine-tuning. Now let's see how this actually shows up in the apps and services you're using probably right now. So remember that question we started with? Here's your answer. The next time you type something into a search engine, you can picture an encoder-only model working behind the scenes, trying to deeply understand what you mean. The next time you're chatting with a bot, you're talking to a decoder-only model, built specifically to generate a fluent conversation. And when you translate a phrase on the fly, that's the classic encoder-decoder team doing its thing. One part understands, the other part generates. So where is all this headed? Well, there's a really interesting clue in this recent quote from some researchers. They're pointing out that because decoder-only models are a bit simpler and more flexible, you can fine-tune one powerful base model to do a whole bunch of different jobs. And a lot of folks in the field think this means they might just become the go-to architecture for tons of applications in the future. You know, when you think about it, the journey from those early, clunky AIs to the powerful, parallel architectures we have today, it's just incredible. We now have this super versatile toolkit for building specialized intelligence. So the only real question left is, what comes next? What new things are we going to build with these tools? That's something to think about. Thanks for tuning in.